The last 6 electron pair case is a one which has 4 of the 6 electron pairs bonding and 2 of them are non-bonding. So 4 bonding, 2 non-bonding, and in this case we take xenon tetra fluoride, xenon tetra fluoride as an example. We calculate the valence electrons. Well, for xenon, well, xenon is a noble gas. Okay, it has 8 valence electrons. Fluorine contributes with 7, and of course fluorine is located in group 7A, the halogens group. So there are 4 of them and each of them contributes 7, so 28 plus 8, that is 36 electrons, 36 valence electrons in xenon tetrafluoride. If you divide that number 36 by 2, so 36 by 2, we get 18 electron pairs, 18 electron pairs in this xenon tetrafluoride example. In order to draw a reasonable Lewis structure, we begin with drawing the central xenon atom like that. So that's xenon, which should be surrounded by 4 fluorine atoms. So these are the 4 fluorine atoms, 4 surrounding atoms. Okay, now we draw a bond between xenon and each of them, each of these surrounding fluorine atoms. Okay, we get something like that. And now, just following the usual practice, each of these fluorine atoms so far is surrounded by 2. So again, we need to make sure that they obey the octet, and that's by drawing or making sure that they are surrounded by 8 electrons. So we need to draw 6 more in addition to the 2 electrons which have already been drawn. So something like that should be reasonable. So there are 8 electrons on each of these fluorine surrounding atoms. 8 times 4, that's 32, but we had 36 electrons to start with, so we have 4 to go, and those 4 additional electrons should be drawn on the central xenon atom like that. So therefore there are 2 lone pairs. If you want to double check this Lewis structure, 8 electrons, 8 valence electrons on each of these fluorine atoms times 4, that's 32, 34, 36, and we had 36 before, so that's reasonable. If you want to check the electron pairs, you will find there are 4 on each of these fluorine atoms, so that's 16, that's another, and that's another. So there are therefore 18 electron pairs on the Lewis structure, and that's in accordance with the number or the information that we have found before. Moving on to the prediction of the orbital shape. Well, the orbital shape is still octahedral because there are 6 electron pairs around xenon, so the arrangement of electron pairs is still octahedral, but the molecular shape will not be octahedral because now not only there is 1 electron, 1 lone pair, but actually there are now 2. If you take 2 of these off, you would find out very clearly that the molecular shape obviously is no longer octahedral, but it takes actually the shape of a square, and this square is actually planar. So the shape therefore is described as square planar. So that's a square planar molecular shape for this xenon tetrafluoride case. So the molecular shape is square planar. It takes the shape of a square which is on the plane. To conclude, in this 6 electronic case where 4 of the electron pairs are bonding and 2 of them are non-bonding, the central atom should have 2 lone pairs. Therefore, the orbital shape or the arrangement of electron pairs is octahedral, whereas the molecular shape is square planar, and that's to account for the presence of 2 lone pairs on the central atom.